All right, everybody, let's look at lesson 4, which is types of solutions and solubility curves. Well, there are three main types of solutions that we're going to talk about. The first one is an unsaturated solution. By definition, an unsaturated solution, more solute will dissolve if you add more crystals into your solution. So that means that all of the space taken up in your solvent is not used yet. You can actually, if you were to add more crystals to your test tube of solution, more will be able to go into it. A saturated solution means that if you were to add more solute into your solvent, nothing else will dissolve. So when you think about this, think about when you are making iced tea or lemonade over the summer and you use those powdered iced tea and those lemonade mixes. When you add too much into your glass of water, no matter how much you stir it around, no more of that powder is going to go into solution. That is a saturated solution. The other is a supersaturated solution. A supersaturated solution is very unstable. In order to make a supersaturated solution, the first thing you need to do is you need to heat up your solvent. When your solvent then cools, what will happen is you'll get crystals that will form at the bottom of your container that your solution is, and that is a supersaturated solution. So, how can we use solubility curves to determine whether a solution is saturated, unsaturated, or supersaturated? So here is the solubility curve of KNO3. And on the y-axis, we're looking at the amount of solid KNO3 that will dissolve per 100 grams of water at various temperatures in degrees Celsius. This line will tell you at each temperature how many grams of KNO3 will dissolve if you wanted to make your solution saturated. That means that that is the exact number of grams of KNO3 that you can place into 100 grams of water. And notice how it gets bigger with the higher temperature. So, if you're talking about, and if I ask you about a question and whether to identify the type of solution, if the values for your grams, the number of solute, and the temperature fall on this line, then no matter what temperature you're at, your solution is saturated. If I ask you for values that are underneath the line, that means that your solution is unsaturated. If I ask you about values that are above the line, then you have a supersaturated solution. So, on your table G in your reference packet, there are three lines that actually go in the opposite direction. They do not go up and to the right. They go down and to the right. What does that mean? Those three lines show decreasing solubility with increasing temperature, and that's because those three lines are the gases. Remember, the solubility of all gases decreases with an increase of temperature because when you increase the temperature, those gases do not want to go into solution. They want to stay and be freely moving around outside. So, how do we determine the type of solution? By looking at table G. First thing you need to do is you need to locate the temperature in the question. Then you go up to the the temperature line, and then you stop when you reach the amount of grams that you have. And remember, if you stop on the curve for the compound that you're talking about, then you have a saturated solution. If you are under, and if you, in more particular, you are under the curve, okay, you are going to be talking about a solution that is unsaturated. If you are above the curve, then you're going to talk about a solution that is supersaturated. So let's look at some examples. So example 1, what type of solution is this? If you dissolve 50 grams of NaNO3 at 30 degrees Celsius, what type of solution did you make? So the first thing we have to do when we look at table G is we have to identify NaNO3. NaNO3 is this line right here. Okay, notice how it's labeled as such. The next thing we need to look at is we need to look at 30 degrees Celsius. And so 30 degrees Celsius is here. And I'm looking at 50 grams. So when we look at this, and we're going 30, and we're going to go all the way up. And we're going to go to 50, which is over here. Okay, so 30 and 50. If we look at this, I am underneath the NaNO3 line. Since I am underneath the NaNO3 line, this is an unsaturated solution. Okay, let's look at the next one. How much will dissolve? Okay, according to table G, what is the maximum amount of KNO3 that can be dissolved in 100 grams of H2O at 60 degrees Celsius? So we're going to look at KNO3 and 60 degrees Celsius. So here we go. So we are going to be looking at 60 degrees Celsius, which is right here. Our KNO3 line is right here. So we're going to look at 60 degrees Celsius. So we're going to start off at 60 degrees Celsius, and we're going to go all the way up to KNO3, which is right here. And then we're going to go over. And that value right there is about halfway. So it'll be 105 grams can dissolve to make a saturated KNO3 solution. Let's look at example 3. You're adding solute to an unsaturated solution. So a solution of KCl contains 20 grams of KCl and 100 grams of water at 30 degrees Celsius. How many more grams of KCl must be added to make the solution saturated? So we're starting off at 30 degrees, which is right here. Starting off at 30 degrees, and we're going to 20 grams. So 30 degrees, 20 grams is right here. And we're talking about KCl. So the KCl line is right here. It's our KCl line. So I want to know how many more grams would I have to add to get a saturated solution. I've already added 20 grams. Now, how much more? How much do I need to add to get it up to here? Well, this is about 35 grams. If we were to go up to this line and then go over, that's about 35 grams. So how many more grams would I have to add? What's the difference between 35 and 20? I would have to add about 15 more grams in order to get this solution saturated. Now, what about the opposite? What if you have a solution and then you cooled it? Sometimes when you cool solutions, crystals will fall out. Well, how many crystals will fall out and become a solid? Okay, so in this case, we're looking at a saturated solution of KNO3 is cooled from 70 to 25 degrees Celsius. How much KNO3 will precipitate or become a solid and settle out? So let's look, we're talking about KNO3, and we're talking about KNO3, which is right here. And we're starting off at 70, so we're going to go up to 70, and we're going to go all the way up to our line. So we are right here, and we're going to go over. So that's about, if I could draw straight, 135. Then we're going to cool it from 70 to 25. So when we cool it to 25, we're at right here. We're going to go all the way up. And we're going to go to where we hit our line. Oop, I went too far. We're going to end right here, which is at 40. Okay, so here's our line. So, what is the difference between 135 and 40? Okay, 135 minus 40 is what value? So, when you do 135 minus 40, what will you end up with? You'll end up with 95. So 95 grams of KNO3 will fall out of solution. Awesome. So now let's look at example 5. So if the problem does not use 100 grams of solvent of water, what if they changed it? What if instead of 100 grams, I use 200 grams or even 400 grams? Well, you can use your table G and then you're going to have to use a little bit of thinking and common sense to figure out the rest. So, according to your reference table G, the amount of NH3 that can dissolve in 200 grams of water is 30 degrees Celsius. Well, what do you know? You know that when you look at your reference table G, that on 45 grams of NH3 will dissolve in 100 grams of water. But instead of 100 grams, you have 200 grams. So you doubled the amount of water you had. So when you double the amount of water you have, what will you do to the amount of solute that you add? So if you have 200 grams of water and instead of 45 grams, you would have 90 grams of water to dissolve in 200 grams. Okay? So we use this and we know that at 45 grams, which is right here when we hit NO3 at 25 degrees Celsius, okay? But now instead of talking about 100 grams of water, we're talking about 200 grams. So instead of 45 grams, we'll be able to put in 90. So let's look at a practice. Pause the video, answer this on your own, and then unpause it when you're ready. Great, well, welcome back. What is the maximum amount of Ki that can be dissolved in 100 grams of water at 20 degrees Celsius? So we got to find our Ki line, which is up here. And I want to know what is the maximum amount that will dissolve at 20 degrees. So we have 20 degrees, which is right here. We're going to go all the way up to where we hit the line, and then we're going to go over. Okay, so that's about 45 grams will dissolve in 100 grams of water of Ki to make a saturated solution. What about if you wanted to make a saturated solution of NaNO3, but then you decide to cool it from 50 degrees to 25 degrees? How much of the NaNO3 will precipitate out and become a solid? Pause the video and answer this, and then unpause when you're ready. Great, well, welcome back. So we're making a saturated solution of NaNO3, and then we're going to cool it from 50 to 25. So NaNO3 is right up here, and then we are going to start off at 50, which is right here. We're going to go all the way up to the line, and then we're going to end up at 25, which is right here. So I want to know how much will fall out. So that's about 105, and this is about 90. So 105 to 90, how much will fall out? That's about 15 grams. So 15 grams will end up falling out of solution. Okay, let's look at another practice. The amount of NaNO3 that can be dissolved in 50 grams of water at 80 degrees Celsius is what? Pause the video, unpause when you're ready. Great, well, welcome back. Well, we're looking at NaNO3, which is this line again, and we want to know how much NaNO3 will dissolve in 50 grams of water at 80 degrees. So we have 80 degrees of water right here, okay? And so we're going to go all the way up till we hit our line. That's about 145. But instead of having 100 grams of water, we now have 50. So we would take 145 and divide it in half, and you would get about 72.5 grams. And so now the new value, instead of 145 grams, would be 72.5 grams would dissolve in your 50 grams of water instead of 145, which would dissolve if you had 100 grams of water. You cut your amount in half, so you have to cut your value in half. Now let's look at these, check your understanding. The amount of KCl that can be dissolved in 100 grams of water at 40 degrees Celsius is how much? And then also, a solution of NH4Cl contains 20 grams of NH4Cl in 100 grams of water at 40 degrees Celsius. How many more grams must be added to make it saturated? Answer these tonight, and we'll talk about them tomorrow in class.